I've got here a 200-watt drone motor, so you might be wondering why I've decided to strap it to my wrist. In the words of my grandma,
Can I sort of start at the very beginning?
I've been working on a device to help mitigate my grandma's tremor. In a previous video, I was able to find some success with a passive tuned mass damper system.
That's amazing.
But I think I can do better. A lot better. In fact, in this video I ended up trying 5 different ideas to see if I can finally beat this tremor. This idea comes from a product, gyro gear, which uses a gyroscope to stabilize the hand. A spinning mass with sufficient angular momentum will resist changes to its axis of rotation and stay steady. Just picture a spinning top, which maintains its balance even if you tap it gently. The keyword here is gently. A top isn't going to resist big forces, and in order to generate enough angular momentum in a spinning mass to steady a shaking hand, we need to spin it really fast. First thing though, I'm just curious what it feels like to hold a gyroscope, so I geared up some computer fan motors and tried to get this mass spinning.
Come on, working before.
These motors just aren't going to cut it, so let me try a brushless DC motor from a drone. This has much more power, and I can clip on some mass to increase the moment of inertia. And moving this around feels very odd. It's not necessarily stable, the side-to-side motion seems to be converting into a sort of rotation of the hand. Now, after looking into this, it turns out that rotation is called nutation, a sort of wobbling around the axis of rotation. The faster we spin, the smaller this becomes, so I either need much more mass or much more speed, but this motor already sounds like a jet trying to take off. So I'm going to try another approach that I encountered while researching satellite stabilization. You may recall that every force has an equal and opposite force. Pushing a ball to the right pushes this person back to the left. The same is true in a rotating frame. If I spin something to the right, it will create an opposite torque spinning to the left. Here you can see if I attach the motor to my hand and start it up, a small torque is applied to my hand in the opposite direction. If I can program this motor to always spin in the opposite direction of the tremor, it could cancel out the forces. That means I need to somehow track the tremor, but I can do that with an accelerometer. This will tell me in which direction the hand is tilting and how quickly. I'll program the motor to rotate in response to the accelerometer. If it tilts one way, the motor spins the opposite way. I'll add some mass to the motor's shaft and attach it to my wrist. Now if I tilt my hand one way, it revs up in the opposite direction. I've modified my tremor simulator from last video to now simulate wrist rotation. The wrist is coupled to the motor only with springs tuned to its oscillating frequency. This just means that the wrist is uncoupled from the motor, so while the motor is driving the wrist to rotate, it can still be held steady. I'll do a test where the device is turned on and one where it is turned off to see if there's a change. The tremor looks like it's reduced, and that's great. However, practically speaking, the device is just too big and too loud. Now I managed to reduce the form factor, but ultimately I wasn't able to get anything that was sufficiently small and powerful enough to be practical. Not to mention, it would have to be battery powered, charged regularly, not get wet, and I think most importantly, it's just completely disruptive in volume. So while in principle that was quite effective, I decided to go back to the drawing board and see if I can improve on the previous passive device. I elaborate more on this in the previous video, but basically, if I can build something with a mass that wants to oscillate at the same frequency as the tremor, the energy from the tremor can go into the mass instead of into the hand. A classic way to get something to oscillate is with springs, and you can calculate what mass and what spring strength you need to get the right oscillation, in our case 5 Hz. The previous version had made use of 4 springs, but ultimately it was too big and was too floppy. So I put together a model for a new version that was a bit more compact and had room for a bunch of springs to account for different angles. After buying a bunch of springs and none of them being quite right, I made my own out of guitar strings. I installed all the springs and wound a copper wire around the outside so that it would have the right mass to oscillate at the right frequency. I put it on the tremor simulator and, well, it was a complete flop. The mass was just way too much for the springs to handle. So I thought, okay, maybe instead of having springs, I'll have the bracelet oscillate using something else, maybe cantilevers. Springs aren't the only thing that can oscillate, lots of things do. I saw some research by Sarah Gabai that showed it might be promising to suppress tremor with a cantilever, i.e. a protruding beam. It's not hard to imagine tapping this beam and that it might oscillate back and forth. So I built my own and tried to keep it as compact as possible. I used a bunch of different materials and masses, and ultimately had the most success with, again, guitar strings. I designed a bracelet with 4 locations for cantilevers to slot into, and brought it to my grandma to test. Guys, I somehow lost that footage. But you're not missing much. While it had a slightly better form factor, it worked a bit worse and kept breaking. And crucially, it was only keeping the wrist steady, which was never the main culprit. The hand was the problem. And this is the thing that took me so long to notice. The hand is shaky, but the wrist mostly isn't. So they gave me a final idea. Forget the high tech. Maybe I can just use a stick. Well, a fancy stick. It could strap onto the wrist and have a handle at the top to hold tight to. Then the hand is braced against the wrist and kept steady. And guys, this idea was so simple that it actually worked.
See, there's like no shaking there.
That's
Minimal.
It's so much better. It's much easier it's an easier movement
Yeah.
into my mouth.
Look at you move, Ma. All right. Oh my gosh. I can't keep up with you. All right,
It's
hold
such
on.
fun, Tristan. You've no idea. I feel quite famous already. Thank you.
There's room for improvement and I'll keep making changes, but this is a result that I'm very much surprised by and very happy with.